Hello friends, I am Neeta Kulkarni and today we are going to discuss about the SONET and SDH optical networks. So it is the point related to chapter number 5. So as we know that chapter number 5 it is divided into two parts. First one it is optical amplifier and second it is optical network. So related to optical amplifier already the video has been uploaded. One more video has been uploaded related to introduction of optical network. So before starting of this SONET or SDH network, let us first revise what we have seen in the introduction of optical network. So in introduction we have seen what is the concept of optical network. Optical network is nothing but it is the connection of different stations where the connections are connected with the help of optical fiber cable and information is transmitting from one station to another in the form of light signal instead of the electrical signal, and based on the type of the network or based on the application of the network, the particular topology it is selected for manufacturing of the network. So topology means the structure in which the stations are connecting to each other. So there are four types of topologies mainly: ring topology, bus topology, star topology and mesh topology. So out of these four, the ring topology it is most commonly used in optical networks. So that topologies we have seen. Then we have seen the types of optical networks based on their coverage area. There are 3-4 types: LAN, WAN, then MAN and trunk stations, or it is also called as the public network. So based on that there are 4 types that we have seen, and we have seen what are the applications of optical network. So these basic points we have seen. Now in this video we are going to specifically discuss about the SONET and SDH network. So let us see first what is the long form. SONET stands for synchronous optical network and SDH stands for synchronous digital hierarchy. So these both networks are combined together. These are the standardized protocol that transfer multiplex digit bit stream synchronously over optical fiber using laser or highly coherent light emitting diode. So simply it is telling that SONET or SDH, that is nothing but that is commonly used optical networks. So these optical networks can transmit the data at very high rate. So for low data rate transmission, the previous system is also used, in which the electrical signal it is used in the formation of the network. So that network it is transmitting the signal in the form of electrical signal. So to replace the previous network, that is commonly known by PDH system, that stands for place synchronous digital hierarchy system. So this SDH it is replacing that PDH system for transmission of the signals with very high data rate. So this SONET it was proposed by Belcore Laboratories. So it was invented by Belcore Laboratories and it is standardized by the institute called as American National Standard Institute, which is known as ANSI. So there are particular institutes. For example, if we consider that ITU stands for International Telecommunication Union. IEEE, that stands for Institute of Electrical and Electronics Engineers. So these are the standard institutes which are certifying any invention related to the communication, or these are the final decision taking committees related to any new invention in the communication. So if anything it is newly invented, that should be certified by the standard institute, then and then only that particular research it is approved. So this is SONET SDH. It is standardized by American National Standard Institute, and a complete version of SONET that is referred as the synchronous digital hierarchy, or it is called as the SDH. So basic goal behind invention of this SONET, it is the main concept in SONET, it is a synchronous network, and the basic agenda behind using this SONET, it is to provide the synchronization. This synchronization it is provided by the SONET network, that is the first goal. Then there are number of applications in optical communication. So there must be some standardization for fiber optic transmission system equipment sold by different manufacturer. So to achieve that synchronization or standardization, this SONET network it is used. Then SONET, it is basically a time division multiplexing system. It basically works on the principle similar to the TDM system. Then SONET is multiplexed transport mechanism, and hence it can be act as carrier for broadband services such as ATM and BISDN services. So it can act as a carrier signal for that particular applications. These are goals of the SONET. Now we will see the architecture of SONET. So basically if we see in the diagram, it consists of mainly three parts. First is synchronous transport signal, that is STS multiplexers, then regenerators, then add or drop multiplexers. So STS multiplexer or demultiplexer, those are acting as a multiplexer as well as the demultiplexer. So we will see the structure in the diagram. If we see the first point, it is terminals. The terminals are nothing but the end users or the stations which are transmitting the signal. Then that signals are given to the STS multiplexer or demultiplexer. Its output it is given to the regenerator. We will see that function. Just first see the flow of the blocks. At center, add drop multiplexer is used. Output of add drop multiplexer is given to the regenerator. Output of regenerator is given to the STS mux demux, and its output it is given to the terminals. So we will see the working of each block one by one. First, but it is mainly divided into three parts: SDS multiplexers or demultiplexers, regenerators, and add drop multiplexers. So see the function one by one. STS multiplexers or demultiplexers are used for two purposes. There are two functions provided by this block. It multiplexes signals from various sources into STS, or it demultiplexes STS signal into various destination signals. So if multiple stations are there or multiple stations are there in the transmitting side, this STS mux it acts as a multiplexer. It combines the different signal and transmit it along a single channel. Then the STS signal passes through a number of regenerators or repeaters while traveling from the source to the destination. Suppose let us consider now that STS block it is acting as a multiplexer. So there are four terminals, means four signals are there at the input of STS multiplexers. That four signals are multiplexed and a single output it is given to the regenerator. The regenerators are basically repeaters or bidirectional devices. So the signal it is transmitted through the regenerator and it is given to the add or drop multiplexer. Then so simultaneously we will cover STS multiplexer or demultiplexer. So at a time that device can act either as a multiplexer or demultiplexer based on how we are using it in the particular block diagram. If it is acting as multiplexer at transmitter side, it will act as a demultiplexer at the receiver side. So we have seen the STS mux or demux regenerators, and the central important block it is add or drop multiplexer. So that is very important point in the block diagram. So add or drop multiplexer is capable of adding the signals from various sources, or it can remove any signal and redirect the demultiplexing the entire multiplexed signal. So add drop multiplexer, that is central important block that can act as multiplexer or it can act as a demultiplexer based on whether we are using mux at transmitter side or demux at the transmitter side. So that is the basic working principle or basic structure of the SONET. Again, the function of regenerators, if we see, they will regenerate the STS applied to them. This will eliminate any effect of additive noise on the quality of the transmission. So as the original signal it is regenerated, effect of noise on the particular system it is reduced. And SONET regenerates function at data link layer. So in networking there are different layers are used. Out of that SONET it regenerates function at the data link layer. So this is the brief block diagram related to the SONET or SDH network. So it mainly, as we discussed in exam, if the question it is asked, you have to draw this block diagram and write down the explanation of these three blocks. So STS, mux or demux, then regenerator, and third it is add drop multiplexer. So based on the application, this particular blocks functioning it is selected, whether it will act as mux or demux, whether it can add multiplexer or it can act as a drop multiplexer at the central side. So here 4 terminals are shown. We can use n number of terminals based on our requirement. So this is the SONET structure and its basic working principle. Now we will see the next point, SONET ring, or it is also called as SONET oblique SDH ring structure. Now as we discussed, there are 4 types of topologies in any optical network. Ring topology, that is most commonly used. FDDI network that we have seen. So FDDI it is also using the ring topology. Apart from that, the different topologies are star topology, mesh topology and bus topology, already we have seen. So in ring topology, why it is called as ring topology? Because the stations are connected in the structure like ring. So first station is connected to second, second is connected to third, and again whatever is the last number of station that is connected to the first one, or we can say the loop it is closed. That's why it is called as the ring topology. So SONET ring structure, it is using the ring topology, means whatever are the number of stations, those are connected in the form of ring structure. Suppose 7 stations are there. First will connect it to second, second to third, third to fourth, fourth to fifth. It will be continued up to 7, and at last the output of 7 it is again connected to the first station. The loop it is closed, that's why it is called as a ring structure. So here for FTDI whatever concept we have seen, same it is applicable here. So here also add drop multiplexers are used, and to that add drop multiplexers the basic stations or basic end users are there which are going to communicate with each other. So in the diagram, the basic users are connecting to each other or communicating to each other with the help of this ring structure. So if we see in the diagram, there are two types of rings. So first it is working rings, or that is called as the primary ring, and second it is the protection ring, that is called as the secondary ring. So whatever is the basic signal transmission taking place, that is taking place through the primary rings, or it is called as the working rings. And in case if there is any problem in the working of primary rings, then secondary rings are acting as a backup for that primary rings. So but the main signal transmission, it is done by the working rings, or it is called as the primary ring. So same point it is explained here. The end users are connected to the add drop multiplexer. Add drop multiplexers are connected to each other with the help of this ring structure, working rings and protection ring. If there is any problem in the working of primary ring at any time, then by default that signal transmission takes place through the secondary rings, or it is called as the protection ring, and the overall function of the network will not be disturbed because of that. That is the basic purpose behind using this protection ring. So this we can also say it as primary ring and secondary ring, where here it is mentioned as working ring and protection rings. So same points are explained here. Primary rings or working rings, it is the main primary working ring which uses the actual optical fiber for transmission of signals from one terminal to another terminal, and it consists of trunk lines, or that is set of optical fiber cables. So there are two cables, means one set it is there in the primary ring. Then secondary ring, it is also consisting of another set of optical fiber which will provide the backup to the primary ring in case of failure of the primary rings. In case if primary rings are broken, automatically the signal it is transmitted through the secondary ring. That is the basic point. And then add drop multiplexers are used to add or drop any channel in the structure in between the working. So you can add any channel in this particular structure, or you can delete any channel from this particular structure with the help of this add drop multiplexer. So this is about the ring topology or ring structure used in the SONET or SDH networks. Then that is about the basic related to SONET and SDH network. If we see the application of SONET, it is used, as we discussed, main thing, it is used as carrier for ISDN and BISDN structure. It is used as carrier for ATM cells. It is used as bandwidth on demand network. So based on the demand, the bandwidth it is provided by this particular system. So it is used as bandwidth on demand network, and it is used for T1 and T3 carrier lines. These are the basic applications of this SONET network. So basically in this point, the question it is asked as explain the SONET or SDH network, or write a short note on SDH or SONET network. So if it is asked for 4 marks, you are supposed to write the basic concept of SONET network, block diagram of SONET, and write down its explanation. If it is asked for 6 marks, you can add the applications of SONET and which ring structure it is used in the SONET. That points can be added related to this particular point. So SONET and SDH, that points are related to each other. Whatever is the complete version of SONET, that is referred as the SDH network. So basic working principle, it is going to be same as the SONET.